All right, so welcome to 13.6 rotations in the coordinate plane. So what is the total amount of degrees in a circle? When you spin all the way around, let's draw that better, spin all the way around like that, that's a 360 degree spin. All right, so find the measurement of each of these angles. Well, hopefully all of those look like right or 90 degree angles. And they're all 90 degrees, but notice they're all oriented differently. So say you took this ray here and rotated it that way 90 degrees, it would look like that. If the ray, let's use a different color, this ray here in black was rotated 90 degrees, it would now be over there. And if this ray was rotated 90 degrees, it would be over there. And the rotation means spinning. So we've learned two types of transformations, and now we're going to learn the third. We've learned translations, where you slide it, reflections, where you flip it, and now rotations, where you spin it. Now, we're going to do all our rotation or spinning around the origin, around 0, 0. So think of 0, 0 as a pole that the object is holding on to, and it's spinning around that pole. So here's an example. This object A, this triangle A, was rotated 90 degrees, right? So if we spun it all the way around, it would be a 360 degree rotation. Most of our rotations today are going to be 90 degrees. So it was lying on the y-axis and it's spun 90 degrees, and now it's lying on the x-axis. So let's do our first rotation. It says rotate A 90 degrees counterclockwise. So if it doesn't say which way to go, with a clock or against a clock, you always go against a clock. So counterclockwise is that way, right? So we're starting here and we're going that way, and we're going 90 degrees. So, right, we're going like that. So let's do this. So try to draw A in its new location. So it spins around 0, 0. Everything stays congruent, because this transformation, just like the other two, everything stays congruent. It's at -5 here, so it's got to be at 5 there. We're going to draw the same object over there, and we're going to call it A prime. And we've rotated or spun that triangle 90 degrees around the origin, right? Now, in high school, you'll spin around other points in the coordinate plane. We're just going to spin around the origin. And so let me erase, and there's the answer. All right, so let's spin or rotate B 90 degrees counterclockwise around the origin. All right, so now it's not touching the pole, so it's got to stay the same distance away from the pole, and it's got to stay the same exact shape. So this side is at 5. It's got to stay 5 away from the origin, and it's got to be the exact same length. It was 6 units, and it was symmetrical. So I almost wrote it at 4. So it's got to be the exact same length. This one that was 2 units away, all right, has to be the exact same length. And I noticed I drew that a little too long. There it is. And there is B prime. And there's a better version of it, slightly. All right, so you went from here 90 degrees. We made a 90 degree angle. So you can actually, some people have trouble with this. So now a hint for those of you who are having trouble. I guarantee there's some people out there going, I don't get this, Mr. Ben. You can literally take the paper you're working on and turn it and see the answer. Right? You might want to try that even if you're getting this. So we're going to rotate C 90 degrees counterclockwise around the origin. And if you turn your paper I've just turned my paper. Now notice the numbers are all wrong all of a sudden. But that's where you're going, right? Before you even start, you can turn your paper and see the answer, right? That's where we're going. So I'm going to go back, and now I'm actually going to do it, right? So this is at -4, so this has to be -4. It has to be the exact same size, right? And it's got to be right there. And this point that was at -4, 2, now seems to be at -2, -4. Well, there's a pattern there, but it's a more complicated pattern than the last 2 days. And this one, -4, -2, is now at 2, -4, and 0, 0 stayed the same. Okay. So that's our 90-degree rotation counterclockwise around the origin. All right, so those were the easy ones. Yes, those were the easy ones. The harder ones are when things are not symmetrical. That's why I was giving you the hint on the last screen. So we're going to rotate this D, and it's got to go over there. Right, so we're going against the clock, counterclockwise around the origin. We still have to aim the exact same distance away from the origin that we are now. Right, so this point is 2 away from the origin. It's got to stay 2 away from the origin over there, and so on. But I'm going to rotate my paper and see the answer before I turn it back and then actually do the work. So I've rotated the paper. The numbers are all wrong, but that's where it's got to go. If you turn your paper, you will see that. That's the image we're trying to create. So let's go back to the original object. So it's got to look exactly like that, and everything's got to be in the same spot. So this is at 7, but it's 2 over from the x-axis. So now it's going to be up at 7, but 2 over from the y-axis. And it's going to look like that. That's what D prime is going to look like. So let me actually write the nice printout of the answer. There's our 90-degree rotation. We've made a 90-degree angle there. And so let's see where the new coordinates are. This is at 2, 0. This is now at 0, 2. This one down here at 2, -2. It's over here at 2, +2. And this one at 7, -2 is way up there at 2, +7. So here is the pattern. You do not need to memorize these patterns, but there are patterns in each of these transformations. Here, you start with x and y. The y goes over to where x was and becomes the opposite. X goes over to y, where y is, and stays the same sign. All right, so let's do the next one. So this is going up here, right? We're going up 90 degrees. So let's turn our picture and see. Oh, I didn't do it this time, so you got to just figure it out. It's got to go up there. So we're at -4, we got to be at +4. We're at -7, we got to be at +7. Right? We got to be the same exact shape, but 90 degrees that way. So it's going to be the same exact shape, but 90 degrees that way. So this is L prime and so on. So let's see that. I have already done it. So there it is. And now let's see if this pattern holds. All right, so H was at 3, -6. So this should go over there and becomes its opposite, 6. This should go over there and stay the same. We should be at 6, 3. Yeah, we are. J, so the -7 goes over there and becomes its opposite. It becomes +7. The other one, the opposite stays the same. It should be at 7, 0. There we are. This one goes over there and becomes its opposite. That one becomes over there and stays the same. We should be at 4, 0. And this one comes over there and becomes its opposite. And this one goes over there and stays the same. We should be at 5, 3. That is the pattern that goes on in every 90-degree rotation counterclockwise. So now we're going to do 180-degree rotations. So to see the answer for a 180-degree rotation, you turn it twice 90, also known as turning your paper upside down. If you turn your paper upside down, you will see where the image is going to be. So let's do that. Right, I've turned my paper upside down, y is on the bottom, all of a sudden the numbers are all in the wrong spot. But that's a 180-degree rotation of this object. It's two 90s. It's 90 twice. You could do it that way. So let's do that. So 180-degree rotations are actually easier because everything just goes, right? And that should look like a reflection to you. It is a reflection across the y-axis in this case. Right, so this is a 180-degree rotation around the origin. Notice I didn't say which direction, because if you go this way or this way, you end up in the same spot. So saying counterclockwise or clockwise is unnecessary for 180-degree rotations. Right, so let's try this one 180 degrees, please. Right, we did it 90 already. So that's 180 degrees. So this thing over here now is there. This one over here, right, if you're in quadrant 4, you're going to end up in quadrant 2 over here. So it's there. This one over at 7 better be at negative 7. Let's see that. I'm sure I drew it nicer. Well, there's the turning of the paper upside down, right? Everything's upside down. And there's the actual answer for C prime. Now, in a rotation of 180 degrees, what's the pattern? Things don't switch positions. They just become their opposites. Very easy pattern. All right, so H prime here, both things should become their opposites. So that should become negative 3. That should become positive 6. So H is there. H prime should be at negative 3, positive 6, way up there. And 0, 7, J prime, should the opposite of 0 is 0, opposite of negative 7, 7. J prime should be up there at 0, 7. And K prime should be at 0, 4. And L prime should be at negative 3, positive 5. Oops, I've got a mistake somewhere here. Negative 3, positive 5. I'm goofed up somewhere. What did I goof up? 0, 4. Oh, 0, 7. Thank you. I put it at 0, 5. There you go. And now it makes sense. Okay. And there's 180 degrees. And there's a better drawing of the object. Right? If it was 90, it would be here. My drawing don't want to go too fast, right? And then you go another 90 and you're at 180. All right, so rotate line segment QR 90 degrees. Now, when you're done, it should make a 90-degree angle. Make sure you get a 90-degree angle. This is tougher. This is actually the standard. All right, so we want, right, so if say we're here, I get a lot of people who put it way over there. That's not a 90-degree angle. So try to do it correctly. Now Q is going to stay there. It's really, where is R, right? Q prime is going to be at 0, 0. What was the pattern? We switched this one over there, right? And then this one came over here, right? And this one switches over there and becomes its opposite. This one just switches over there. So 3, negative 6 is right there. And look at that. That's a 90-degree angle there, right? If you're over here, which a lot of people do, that's not it. There's a better drawing of it. Are QR, line segment QR and line segment Q prime R prime perpendicular? What's the definition of perpendicular? Two line segments that are 90 degrees. Yes, they are perpendicular. We're seeing if you remember that vocabulary word. All right. Rotate QR 180 degrees around the origin and find the new endpoints. All right, so remember, we just did this to -6. So there it is for 90. So now we got to go another 90 over there. Right? For 180 degree rotation, everything just becomes its opposite. So we better end up over there, right? And now we have 180 degrees in our angle. And there's a better drawing of it. This takes practice for some people. Take your time, turn the paper. That is my best hint if you're struggling with this. Good luck.